Welcome back to our 6-part series about division by zero. In the second part, we'll introduce the hypercomplex numbers and some others. Last time we introduced the zero unit, z, equal to 1 divided by 0, and constructed zero numbers of the form cz, where z is 1 divided by 0, and c is an real number. We also saw that complex number can be represented in a two-dimensional plane with an axis for the real part and an axis for the imaginary part of the numbers. Now we can extend this plane into a three-dimensional space by adding a third axis for the zero numbers. Every zero number is located somewhere on the zero part axis or the z-axis. For instance, the zero number 4z is located here. In this three-dimensional space, we can represent new numbers, which are combinations of real, imaginary, and zero numbers. We'll call them the hypercomplex numbers. A hypercomplex number h is a number of the form a plus bi plus cz, where I is the imaginary unit, the square root of -1, and z is the zero unit, 1 divided by 0. A, b, and c are real numbers. A is called the real part of hypercomplex number h, b is the imaginary part, and c is called the zero part of h. We'll call the set of hypercomplex numbers h. Every hypercomplex number can be represented by a point within this three-dimensional space. For instance, the hypercomplex number 2 plus 3i plus 4z is represented as follows in the three-dimensional space of hypercomplex numbers. In this three-dimensional space, we still recognize the plane of complex numbers c's, indicated in blue here. But we can also introduce a new type of number, the real zero numbers. Those are hypercomplex numbers where the complex part is 0. So numbers that only have a real part and a zero part. We'll call the set of real zero numbers B. Likewise, imaginary zero numbers would be hypercomplex numbers where the real part is 0. So numbers that only have an imaginary and a zero part. The set of imaginary zero numbers will be called A, and it is represented as a two-dimensional plane in red here. And here you see the combination. The hypercomplex space has some subsets in 2 dimensions, the sets C, B, and A. Here's an overview of all kinds of numbers we have until now. When we have a hypercomplex number h of the form a plus bi plus cz, when b and c are 0, we're only left with a, and that is a real number. When a and c are 0, the number becomes b times I, which is an imaginary number. And likewise, when a and b are 0, but c is not 0, we get the zero number cz. When only c equals 0, we get the complex number a plus bi. And when b is 0, we get the real zero number a plus cz, belonging to the set B of real zero numbers. When the real part, a, of the hypercomplex number is 0, we get the imaginary zero number bi plus cz, belonging to the set A. And finally, when none of the components a, b, c are 0, we get the hypercomplex number a plus bi plus cz. To conclude this video, I introduce the conjugates of hypercomplex numbers. We know that when we have a complex number c, which is of the form a plus bi, its conjugate is indicated as c star and defined as a minus bi. Likewise, hypercomplex numbers of the form a plus bi plus zc have conjugates. Let us first consider the special case where b is equal to 0, so we get a real zero number, a plus cz. The conjugate of this number, h star, is a minus cz. And likewise, the imaginary zero number h equals bi plus cz, and its conjugate, h star, will be bi minus cz. Now, when none of the coefficients a, b, and c are 0, we can get three different types of conjugates of the number h. hi star, which would be a minus bi plus cz, hz star, which would be a plus bi minus cz, and finally hiz star, which is a minus bi minus cz. In the next video, we'll do some algebraic operations with hypercomplex number, and we'll introduce a new kind of numbers, the metacomplex numbers. In the description below, there's a link to an article I wrote about this subject. And please leave your remarks in the comment section below. Thank you for watching.